So, very good evening to one and all present here. Today, we are going to see about the dynamic programming concepts in operation research. So, it is basically a quantitative mathematical modeling technique which tries to optimize the n number of the resources in order to maximize the profit as a major outcome. So, it is a multi-stage decision-making problem. Let us see practically in later part of the slide why dynamic programming is called as a multi-stage decision-making problem. Before moving to the next slide, here there are the variables should be initialized in solving a problem related to dynamic programming. One is a stage variable, the other one is a state variable. So the first one is a stage variable. So if I have a large size problem, we can break down the larger size problem into small number of branches or subproblems, and each subproblem is referred to as a stage. Then, what is state variable? A variable which specify the condition or the current status of the system, we call it as a state variable. Let us understand with an example what is stage variable and state variable. Okay, let us go with the numerical exercise. So here, a medical manufacturing concern has 9 medical sales representatives working in 3 different geographical sales areas. The profitability for each representative in 3 sales areas are documented in the next slide as shown in the table. Before solving this exercise, here I just want to say which one is a stage variable and state variable. So, number of geographical region 3. So that is called as a stage, number of stages. In 3 different areas, we have to plan our sales of medicine by appointing 9 sales representatives. So number of area requirement, we will treat that as a stage variable. Then what is a state variable? Total number of available sales representative is a state variable. So now you can see the definition. So state variable is nothing but which specify the condition of the decision process. And based on that, we can summarize the current state of the system. And here, from the available number of stages, total number of stages, we can break down the problem into small nuclear cases, subproblem, and we can detailedly analyze each stage. So these are the 2 terminologies that are noted in dynamic programming model. So now we will go with the problem exercise. Much more further details follows in the next slide. So I told you the data are given in the table. The profitability cost measured in thousands of rupees. So number of sales area to be covered 3 and total number of sales representative 0 to 9. So how to read this table? Suppose if there is no salesman allotted, say 0, so in area 1, so 32,000 rupees, the profitability cost allotted for area 1. Similarly for area 2, 37,000 rupees. Then for area 3, 44,000 rupees. Next row, suppose if I am appointing 1 sales representative in area 1, 2 and 3, the corresponding cost figures are given in the table. 47,000 for area 2 and 56,000 for area 3. Then if I am placing 2 sales representative in area 1, so what is the profitability cost in terms of thousands of rupees? 62,000 rupees. In area 2, 54,000 rupees. In area 3, 62,000 rupees. The next row, suppose I am appointing 3 sales representative from area 1, 72,000 amount, the money, the budget I can allocate, 66,000 I can allocate for area 2 and 72,000 for area 3 is allotted. Then 4 sales representative. So for appointing 4 sales representative in area 1, how much amount we can allocate? 81,000 rupees to earn a profit. Then area 2, total amount to be allocated 74,000 rupees, and area 3, 84,000 rupees. Next, for appointing 5 sales representative in area 1, 92,000 rupees, area 2, 84,000 rupees, and area 3, 97,000 rupees. These are the money which is distributed in 3 different areas. Then, if I allocate 6 sales representative, say in area 1, 100,000, that is 1 lakh, then area 2, 95,000, then 1 lakh 4,000, area 3. Then, suppose I am placing 7 sales representative in area 1, 1 lakh 7,000 rupees is planned, then 1 lakh in area 2, 1 lakh 12,000 in area 3. If I am placing 8 sales representative in area 1, so I can say 1 lakh 2,000, area 2, 1 lakh 2,000, then area 3, 1 lakh 12,000. Then number of sales representatives, say 9. So from area 1, 92,000. From area 2, 1 lakh 2,000. In area 3, 1 lakh 12,000. So these are the individual cost figures planned for 3 number of sales region. Now we have to determine the optimal allocation of medical representative in order to maximize the profit, that is revenue. How many number of medical representative in area 1, 2, and 3 you are going to place it? So solution. So as I've already told you, initialize which are the state variable and stage variable. So we know that the number of sales region identified here is 3. So we can say as a state variable. Number of representative, sales representative, say 9, 0 to 9. Totally 10. So we call as a state variable. Now consider stage 1. Take area 1. So write down the data from the main table. Take the area 1 detail. Write down the cost detail separately. Number of representative 0 to 1. So from area 1, what is the profit cost? How much rupees? 32,000 for 0. 0 represents no availability of sales representative. 1 represents 1 sales representative in area 1. 2 represents 2 sales representative in area 1. Likewise, 3, 4, 5, 6, 7, 8, and 9. So these are the number of availability of sales person from area 1. And the corresponding cost elements are tabulated for your kind reference, which is shown here. Next procedure. Consider the first 2 area 1 and area 2. Combine area 1 and area 2. Okay. So we want to find out the total profit. So here 9 representatives can be solved in 10 different ways. Okay, so now draw the table. Put area 1 and area 2 using split cell option. So F1 of x1, where F1 is the functional variable, x1 is nothing but the decision variable. X1 is the total revenue, the profit cost. Okay, so here we need to combine area 1 and area 2. In the total, in this corresponding cell, we have to find out what is the total profit cost by combining area 1 detail and area 2 cost details. So the cost detail for area 1 and area 2 are given horizontally and vertical column. Okay, now start from corresponding row 0. 0 represents no availability of sales representative. From area 2, 0 represents the same meaning from area 1. So what is the individual profit cost? 37,000, 32,000. Add these two numbers and find out the total, the profit cost. So 69,000. How? 37 plus 32. Likewise, do the same operation, similar operation till up to the last column. So 37 plus 47. Likewise, 37 plus 62. What is the total number which I am getting here? Okay. So fill up these values in the corresponding row. Then next, for the column also, we have to do the same model, same exercise. So take area 2. If I am placing one sales representative from area 2, but in area 1, 0, there is no sales representative. So I want to find out the total profit cost in the next available row, right? So what is the cost details given here? 47 plus 32, 79. So 54 plus 32, 86. 66 plus 32, 98. Like that, we need to calculate the cost for the last, up to the last row, column wise, till up to the last row. So you have to fill this column. Okay. So now we have calculated the total profit cost column wise and also row wise. Now, next thing, for the remaining rows, we need to tabulate the total profit cost by combining area 1 and area 2 cost detail. Okay, how many sales representative are there? 9. Okay, but here from area 2 out of 9, I am placing one medical representative in area 1 medical representative. So what will be the remaining resource constraint? I can able to adjust it. So 9 minus 1, 8. Up to 8 representative I can allocate. Okay, in this corresponding row, I can able to find out what is the total profitable cost for the maximum number of the sales representative that can be allocated the particular row by adding area 1 and area 2. If you don't understand, let us take the next row. Please listen carefully. So now from area 2, I am placing 2 sales representative, but the total number of representative available is 9. 9 minus 2, 7. Okay. So up to 7 number of representative, medical representative, we can allocate the total profitability cost by adding area 1 and area 2. Okay. Likewise, do the same similar exercise up to the last but one row, up to the previous row. Okay. So once again, I repeat the same procedure. So now I'm placing 3 representative. Total available representative is 9. 9 minus 3, 5. Okay. Then next one, 9 minus 5, 4. So like that, we need to fix the number of resource constraint. The total number should not cross beyond 9. Because that is the resource constraint limitation. So our resource constraint should be less than or equal to 9. So total number of sales representative is 9. So we should not plan our profit, the total profit more than the fixed number of sales representative. So we are subtracting from the available resource constraint, we are subtracting with the current independent rows. Now, next one, we need to calculate the maximum total profit. The red color, the image that is indicated in each rows and column, that is nothing but selection of maximum, the total maximum profit. How? On diagonal basis. Okay, say here 69 is in this row 69 we can take, that is the first available maximum number, total maximum profit to be identified. Select that box, then take the diagonal line 79, 84. 84 is the biggest value. Select this box, then 86, 94, 99. So through this diagonal line, so select the bigger value. Out of the three number, last one is the maximum profit, total profit. So like that, we have to follow each way by fixing a diagonal line. By fixing a diagonal line, so we can able to trace the maximum total profit cost. And these are the selected the profit cost that is given in a different color shade, red color image. Now we want to summarize these the chosen, the selected the total profit cost. Okay, so this is the result, the summary. So total profit F1 plus F2. Okay, so summarize these values: 69, 84, 99, 109, 119, 129, 139, 147, 158, and 167. Okay, how I'm getting this value? See from the previous table, previous slide. Okay, by following the diagonal approach, by comparing the relativity of the individual, the cost figure, I have selected the maximum total profit cost. Okay, so these selected numbers we want to enter in the result summary. Okay. So how do I get this number 0 plus 0? What it means? So from area 1, 0 sales representative, area 2, 0 sales representative. If I add, I'm getting this maximum total profit cost. So that is the meaning which we can understand for the remaining columns. Okay, number of representative in area 3, we want to calculate number of representative to be allotted in area 3. First thing, we have combined area 1 and 2, and this is the net result answer which is available. Now, along with this answer, we want to add area 3 details also. So see the formula, x3 plus x2 plus x1. Combine all the three area and identify which is the maximum profit, and accordingly plan the number of the manpower requirement. This is what asked in the problem. Okay, so follow the backward function approach. So allocate the number of sales representative in reverse order by backward function. 9, 8, 7, 6, 5, 4, 3, 2, 1, 0. Okay, right? So from the initial table for area 3, okay, these are the profit cost details which is given. So start from the reverse order, maximum to lowest number. Okay, rewrite it here. Now we need to find out the total profit by combining x1, x2 and x3, all the three decision variable. So 69, already we have combined x1 and x2, that is the total answer, net answer. So now we are going to add x3 with x1 plus x2. 69 plus 112. So what is the net answer? 181. Likewise, 84 plus 112, 196. 99 plus 112, 211. So find out the total profit by combining the three area and record it here. Now out of this available solution, here 216, that is 2,16,000, that is the maximum total profit when we are adding all the three different sales area, okay, out of the available remaining other solution. Okay, so I can take from area 3, 5 medical representative can be allotted out of 9. Area 3, 5 can be allotted. Then what happened? Area 1 and 2. Here remaining is 4 sales representative. How will you split up this 4 in both area 1 and 2? Say 3 can be allotted in area 2, 1 can be allotted in area 1. So totally 4. You can see the solution. Maximum profit is said to be 2,16,000 rupees for the available number of 9 number of medical representative. So how to optimize the manpower constraint? Say area 3, 5 medical representative you can schedule it. Then remaining 4 sales representative. So take area 2, you can appoint 1, and area 1, we can appoint 3. The 4 can be splitted in this way. So totally we have balanced the resource constraint. Okay, now you are able to follow me what is dynamic programming, why this is called as a mathematical decision problem, optimization problem. When a given set of resources are given available, we want to select the best possible combination in order to maximize the profit by minimizing the number of risk involved in alternative selection. So therefore, this kind of dynamic programming model, we call it as a mathematical optimization problem. So with this, I thank each and every one of you for your continuous support and listening to my every session, which I'm posting it in each and every day. So keep forwarding the channel link to your neighbor. Thank you one and all. Thank you once again. We will meet in the next class, the different topic.